All right, welcome. This is video number 5 for our bonding unit. For this, you are going to need your notes open. You're going to need your notes open to page 36. You'll also need your reference table, and we're going to be referring to several sections of the reference table today, both the periodic table and table E, so a new part of our reference table. So polyatomic ions. This video is an introduction to polyatomic ions. So first of all, prefix poly. What does the prefix poly mean? The prefix poly means many. It's the opposite of something like mono or uni, which only means one. So poly means many. So a word like polyatomic means many ions. Diatomic means two. Polyatomic means many atoms. Diatomic means two atoms. Monatomic means one atom. Polyatomic, many atoms. So what is a polyatomic ion? Well, quite simply, it's an ion that's made of many atoms, as the name might imply, right? Polyatomic, many atoms in this ion. Well, what does that mean? It's a tightly bonded group of atoms, and that's key. So we have this group of atoms that are really well bonded together, but it's the group of atoms that has a positive or negative charge. So this group of atoms is not electrically neutral. This is a group of atoms that's going around carrying a charge, and it's behaving as a unit. So it's kind of like one thing, even though there are many atoms in it. It's many atoms that are sort of grouped together like a thing, sort of like a clique at school, a group of students that kind of go around together and function as a unit, for good or evil. The polyatomic ions that we have in chemistry are typically nonmetals. So we actually have this group of nonmetals that are really tightly bonded together that carry this overall charge. We can have polyatomic ions that have some metals in there, but most of our polyatomics are nonmetals altogether. So therefore, if we have these nonmetals that are tightly bonded together, what type of bonding are we going to have? Oh, hey, right? Nonmetals, we should be very comfortable with that, right? Nonmetal plus nonmetal equals covalent bonding. And if you have a look at reference table E, which I would like you to do, reference table E is a listing of our common polyatomic ions in chemistry. If you have a look at these polyatomic ions, you'll notice that they have a formula, and their formula is mostly nonmetals. For example, carbonate, CO3 with a charge of -2. Well, that's carbon and oxygen. Those are two nonmetals. So in the carbonate ion, we have covalent bonding between the C and the O, between the nonmetals. But those two nonmetals together, they are bonded in such a way that they carry this overall charge of -2. So they're functioning, the carbon and the 3 oxygens are functioning as a group, but they carry this -2 charge. Because they carry a charge, they are an ion, right? They're a charged particle. So therefore, they can make ionic bonds as a group with other ions. So notice, what are we looking at here? We're looking at things that have covalent bonding that can then form ionic bonds. So kind of crazy, right? We're blending our types of bondings together. So for an example, consider a compound that contains a polyatomic ion, Na2CO3. So if I were to draw the Lewis structures for that, right, sodium would look like this. Because it's the sodium ion, it's Na+1, and there would be 2 of them. All right, Na2, as it says. It's lost its 1 valence electron, it's ionically bonded, so it's carrying this +1 charge. But then we have the carbonate bit. So I'm just going to draw the Lewis structure for the carbonate pretty quickly up here. And I'm putting this thing in brackets because it's an ion and it carries an overall charge of -2. So this shows the bonding that's happening, and it represents the Lewis structures, the structural formulas for all of the atoms and ions in sodium carbonate, Na2CO3. So list the types of elements that we have. Well, in Na2CO3, we have sodium, which is a metal, we have carbon, which is a nonmetal, and then we have oxygen, which is another nonmetal. So what type of bonding would we have in this compound that has a metal, a nonmetal, and then another nonmetal? Well, looking back at the structure, to answer this question, what type of bonding, I noticed that I have this right here, right? I have this bonding between a carbon and an oxygen. This right here is covalent bonding. Notice I'm showing the dashes. Right, we only do that for covalent bonding. So that's a covalent bond, right? That's a covalent bond. This right here is a covalent bond. So we have covalent bonding. So we've got covalent. But that's not the only thing that's going on in this compound, because I also have these sodiums that have this +1 charge that are being attracted to this -2 charge that the carbonate has. So I have a force of attraction between that, right? This +1 is attracted to this -2. This +1 is attracted to this -2. What type of bonding is that? That's ionic bonding. Right there, right? Bonding between ions, bonding between a positive charge and a negative charge. So I also have ionic. So the answer to the question, what type of bonding would be present? Both. We have both types of bonding if we have a compound that contains an ionic, a polyatomic ion. So the key point here, compounds that contain polyatomic ions, right, plus another ion, so it's not just the polyatomic, it's the polyatomic bonded with something else, they will contain both ionic and covalent bonding. That's a massive, massive, massive key point. If you have a compound that contains something from table E, it will have both ionic and covalent bonding. How can you recognize that? Now, most of the time, it's going to look like this. These are going to be the things that you have in your formula. You don't just have a metal and a nonmetal. You don't just have two nonmetals. You're going to need at least three. Right? You're going to need at least three elements. If it's three, table E, that's a little saying I'm going to have that I'm going to whip out, especially when we're doing naming. If it's three, table E, if you have three elements and you've got a metal, a nonmetal, and another nonmetal, you're going to have both types of bonding. So just a little bit of a practice, because we're going to be practicing this in class. What type of bonding do we have in these different compounds? First of all, sodium chloride, well, what is that? It's a metal and a nonmetal. Okay, metal and nonmetal, just two, ionic. We've seen that before, right? Metal and nonmetal, ionic. Next up, NaClO3. So what do we have here? We have a metal, we have a nonmetal in chlorine, and then we have another nonmetal in oxygen. So this is an example of the polyatomic. The ClO3 is the polyatomic ion. You look that up on table E, that's called chlorate. That's a polyatomic ion. So that means that we have both. We have both types of bonds. We have metal, nonmetal, we have both ionic and covalent bonding. Next up, carbon dioxide. Carbon is a nonmetal, oxygen is a nonmetal. We have two nonmetals, and that's all we have, so I've got covalent bonding, right? Nonmetal is covalent. Next up, ClF3, chlorine and fluorine. Well, again, chlorine's a nonmetal, fluorine is another nonmetal, bonding between two nonmetals, that's covalent. Next up, K2SO4, categorize the types of elements. Potassium is a metal, sulfur is a nonmetal, oxygen is very much a nonmetal. So here's again that instance of the polyatomic, SO4. That's called sulfate. It functions as a unit, but it's got covalent bonding in it. So I have ionic between the potassium and the sulfate, but then I'm going to have covalent within the sulfate. So metal, nonmetal, that's both. And again, just to be very, very clear, these are our big points right here. If you have a metal and a nonmetal, that's ionic bonding. If you have two nonmetals, that's covalent bonding. But if you have a metal, a nonmetal, and then another nonmetal, you're going to have both types of bonding. So we'll be doing some categorizing in class and doing some reading on polyatomic ions.